Welcome to episode 24 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes that object so interesting to astronomers. So I will now turn on the random number generator.
Okay.
So I need to wait a second for the smoke to clear, and I need to wait for a little blinking white light to stop blinking. Okay, and the coordinates from the random number generator are 8 hours, 23 minutes, 9.8 seconds for ascension, and plus 1 degree, 59 minutes, 13 seconds declination. This points to the star system PSR 0820 plus 02 in the constellation Canis Minor. The letters PSR in the name for this star system stand for pulsar, and the numbers are the coordinates for the pulsar in an older coordinate system which was in use when the pulsar was first identified and when the first science papers were written about it. Just to review, a pulsar is a type of neutron star which is the dense remnant of a very massive star that has exploded as a supernova. Initially, a neutron star will spin because it retains the angular momentum of the star that it formed out of. The way angular momentum works, if you take a very wide object spinning very slowly and then squeeze it into a very small space, it will spin very fast. Stars like the Sun complete one revolution on its axis every 25 to 30 days or so. Pulsars, which are the same mass as ordinary stars but which can be around 20 kilometers in diameter, can complete a revolution on timescales of a second or less. This spinning, combined with strong magnetic fields, causes pulsars to emit very short pulses of electromagnetic radiation, but they usually slow down over time and their magnetic fields usually decay. PSR 0820 plus 02, which produces a pulse of radiation once every 0.8648 seconds, was discovered in 1977 as part of a radio wave survey of pulsars. At first, it didn't look that different from any other pulsar, but while astronomers monitored the pulsar, they observed that its pulsation period decreased slightly in 1977 and 1978, and then began to increase slightly in 1979. The astronomers quickly figured out that this variation in pulse emission period occurred because the pulsar was in orbit around another star and the emission was slightly Doppler shifted as it moved around in its orbit. This was rather exciting at the time, as this was only the second pulsar that had been identified to be in the binary star system. Careful observations of the radio waves from the pulsar demonstrated that the pulsar and its companion orbited each other once every 1,232 days. However, it was not immediately clear what the other star was because it did not produce any radio waves itself. Telescope observations in the visible part of the spectrum eventually identified the companion star as a white dwarf, which is the remnant of a sun-like star after it evolves first into a red giant and then eventually into a planetary nebula. In other words, this binary star system contains the cores of two dead stars. Further observations demonstrate that the white dwarf has a mass of 0.6 times the mass of the Sun and a surface temperature of about 14,700 degrees Celsius. Eventually, astronomers discovered some inconsistencies in their observations. As I mentioned before, pulsars are expected to slow down over time, and the period of PSR 0820 plus 02 indicated that it should be a relatively young pulsar in astronomical terms, with an age of about 100 million years. Or in other words, it should have formed 35 million years before the dinosaurs died out. However, white dwarfs should cool after they form, and the temperature of the white dwarf in the PSR 0820 plus 02 system indicated that it formed 200 million years ago, or just a few million years after dinosaurs first appeared on Earth. Based on what astronomers know about the evolution of stars, the more massive star that formed the pulsar should have died much sooner than the less massive star that formed the white dwarf. So it doesn't make much sense that the pulsar seems younger than the white dwarf or most species of stegosaurs. This inconsistency cannot be explained if stegosaurs actually evolved later in paleontology terms, but it can be explained if the pulsar was spun up again by some process involving an interaction with the star that became the white dwarf. The model that describes this process has several stages. To begin with, the PSR 0820 plus 02 star system would have started out with two stars that fuse hydrogen into helium in their cores like the Sun, but one of these stars was much more massive than the other one. The more massive star would have used up all of the hydrogen in its core and gone through a series of changes where it would eventually explode as a supernova, leaving behind a neutron star. The neutron star would initially rotate very fast and look like a rapidly rotating pulsar, but it would eventually slow down and become a more boring neutron star. Next, the less massive star would have run out of hydrogen in its core and it would expand to become a red giant. When the less massive star expanded, its outer atmosphere would get close enough to the neutron star that the neutron star would strip the gas away. Because of the conservation of angular momentum, the gas falling into the neutron star would initially be moving very slowly when it was very far away, but it would move very fast as it fell inwards. This would speed up the rotation of the neutron star, and it would look like a rapidly rotating pulsar again, possibly spinning even faster than when it first formed. The red giant would eventually form a planetary nebula and leave behind a white dwarf that would continue to orbit the pulsar that, as we observe it today, has not yet slowed down after being spun up again. This process appears to have taken place in a lot of other pulsars and binary star systems as well. It's all very messy and complicated, but astronomers would not be interested in PSR 0820 plus 02 if it was simple and boring. The location on the Earth's surface corresponding to the position of PSR 0820 plus 02 in the sky is in the ocean near Indonesia. More specifically, it's a location in the Molucca Sea, about 90 kilometers northeast of Bitung, which is on the island of Sulawesi, or about 45 kilometers east of Biaro Island. The website for this podcast is www.randomastronomicalobject.com. You can visit the website to download episodes of the show, read information about the astronomical objects, view images of those astronomical objects, and send me random feedback. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, which is distributed by filmmusic.io under a CC 4.0 attribution license. The sound effects are from the Free Sounds Project at www.freesounds.org. Thanks for listening.